Hello! This video is an introduction to Linux file system permissions. I will explain what permissions are, how file ownership and group association works, and how to change permissions to control file access for yourself and other users on your system. Understanding file system permissions is very important. Many users, even experienced ones, are confused about them and see permissions as something they simply turn off. I am using air quotes here. They set permissions that are too broad or unnecessary, failing to keep the files private and possibly compromising the system's security. Each file and directory on a Linux file system has a set of permission flags which outline who can do what with them. We can see current permissions using ls command by adding -l option, which gives us the long listing. I have here in my example directory a file called password.list and a directory called sources. Right now, I am the only one who can read and write password.list file, while sources directory is shared with other users on the system. Character 1 shown in the first column of ls command output describes the file type. For example, a D indicates a directory, while a dash indicates a regular file. Permissions are shown as characters 2 through 10 in this column. Current permissions are indicated by various characters with letters R, W, X, and dash being the most common. The meaning of these is mostly self-explanatory. R stands for read, W stands for write, and X stands for execute. For regular files, read means the file contents can be viewed or the file can be copied. Write permission means that the file content can be changed, while execute means the file is a program which can be run. The file type and permissions are shown together for a reason. While they look similar for regular files and directories, their effect is different depending on file type. In this video, I will focus on regular files and discuss directory permissions in the next lesson. The 9 permission characters in the permission string are logically tied in threes. The first 3 permission characters apply to user, otherwise known as owner of the file. Characters 4 through 6 apply to the group user belongs to, while characters 7 through 9 apply to everyone else, collectively referred to as others. In the context of file system permissions, groups are collections of system accounts which can share files with each other by controlling permissions on them, while others refer to everyone else. Such three-tier breakdown allows file owners to control access to their files for themselves and the other 2 communities separately. It is worth noting that permissions do not apply to the system administrator, called root user, who has unrestricted access to the entire file system. You cannot use permissions to prevent root user to access your files, including the ability to delete them. Each subset of the 3 permission characters always comes in the RWX order. If a specific letter is visible, then that permission is set or allowed, otherwise there is a dash in its place. The owner of a file controls permissions on that file, and file ownership and group association is established when a file is created. The long ls output shows file ownership and user group association. Column 3 tells us who owns the file, while column 4 displays which group may have access to it. I am currently logged in as user pi, and this user belongs to a group pi. You can always check your group association using id command. User pi happens to belong to several user groups, but pi group is set as default for that user, so any files user pi creates will be associated with pi group. File ownership and group association typically is not changed. The system administrator has the option to change these parameters using restricted commands, but regular users normally cannot do it. Permissions, on the other hand, can be changed by the users for all files and directories they own. Let me create a new file called monday.txt using Nano Editor. I will put some text into it so the file is not 0 in size to make it a bit more interesting than if I just use the touch command to create an empty file. Here it is. A new file, however made, receives a default set of permissions when created, which in this case is read and write permission for me, and read permissions for group and others. Default permissions are a system setting which varies between Linux distributions. Each user can customize the defaults, and I will show you how to do that in the next lesson. You would be rightfully concerned seeing that the group, and especially others, have read access to my newly created file by default. Depending in which directory a file is created, this could mean that my new file is world readable. It is possible that the entire internet can read this file right now, as others really mean everyone. Linux file system permissions as a concept were invented decades ago in a different, smaller, and more trusting world. For better or for worse, this open access philosophy remains in place. Unfortunately, you will not have a secure system unless you manage permissions properly. Existing permissions are changed using chmod command, sometimes pronounced chmod, which stands for change file mode. The permission flags are manipulated for user, group, and others using standard plus, minus, and equal mathematical operators, which respectively add or subtract from permissions already set or overwrite them. For example, here's how I would add write permission for group for monday.txt file. This command reads as change permissions for group by adding write flag to file monday.txt. Or here's how I would take away read permission from others. This command reads as from others remove read permission. Now others have no permissions to monday.txt file at all. It is important to note that the middle portion of the command does not have any spaces around the mathematical operator. The only spaces used here separate the command, permissions, and the file name from each other. We can add and remove permissions at the same time. For example, now I will take away write permission while adding execute flag for myself. Notice how monday.txt file name changed color in ls command output now that execute flag designates it as a program. The ls command uses color to distinguish between different file types. Regular files are shown in white by default, directories are blue, and programs are green on my system. We can change permissions for user, group, and others at the same time with a single command. For example, now I will take away write permission from group and add read permission for others. In such scenario, the permissions for different entities are separated by a comma. Again, the only spaces used are between the command and permissions and between permissions and the file name. Beginners routinely put spaces around the comma, which is incorrect syntax, resulting in an error message. We can combine U, G, and O letters in chmod command if setting the same permissions for them. For example, if I would like to add write permission for myself and others, I could do it like this. But the command can be shortened like that. This time there is no comma in the permission token. A comma is only used when different permissions are set for user, group, or others. As you can probably guess, setting the same permissions for everyone uses all three indicator letters, U, G, O, like this. But for that special case, we can use A indicator, which stands for all, to shorten the command. For example, now I will take away write permission from all. In this case, group did not have write permission to begin with. The chmod command will always try to apply permissions as specified, but it will not complain if the permissions are already the correct ones. The equal operator clears existing permissions and assigns new ones. Some users find this operator easier to understand than plus or minus, and it's really a matter of personal preference which one they use regularly. For example, now I will make sure that group has no permissions while others have only execute permission. Setting permissions to equal to blank means set the permissions to nothing. By the way, you cannot permanently lock yourself out from accessing your own files by taking away your own permissions. You can always set permissions later to get the access back. For example, I will remove all permissions from monday.txt file so no one can access it. And now I give myself read and write permissions to the file. Alright, now that you have an idea how to change permissions, let me explain how specific permissions affect command line behavior. Permissions for regular files describe what can be done with the file contents, applicable to user, group, and others separately. In general, most user-created files will have or should have read permission and write permission set for the owner and no permissions for group and others, just like you see with my password.list file. This is typically sufficient or appropriate for day-to-day file access, allowing us to view, copy, and change the contents of files we own while securing them from outside access. Permissions for group and others should only be granted when needed. The write flag can be removed to make the file read-only, assuming that read permission is set, of course, providing some protection against changing the file contents accidentally. The execute flag is assigned rarely to regular files, only to program files which are meant to be executed directly. Most user-created files are typically not programs, so they would not have that flag set. I will focus on read and write permissions for now, and will have a separate video to introduce shell scripting, where I will explain the use of execute flag with regular files. My password.list file has read and write permissions right now for me. The read permission allows me to access or view the file contents, for example by opening it in a text editor such as Nano. There is some content in the file, so it was read and displayed by the editor. In the editor, I can change existing or add new contents, including making the file blank. Because I have write permission, I can make these changes permanent by saving the file. I save the updated file and exit the editor. Looking at the file details, I can see that it has increased in size to account for the text I just added to it. Read permission also allows me to copy the file, for example, for the purpose of making a backup. Notice that the permissions of the copied file are the same as the original. Default permissions do not apply in this case, and group and others did not get the default read access to the backup file. Should I change permissions on the backup file, for example by making it read-only, it will have no effect on the original file's permissions. While the files have identical contents right now, they are separate entities and have their own permission settings. When I open the backup file in the Nano editor, I get a warning that the file is unwritable. Should I make changes to the contents and attempt to save it, the editor will refuse, citing permission denied. Having said that, read-only permission for regular files we own is soft, and it can be temporarily overridden. Many commands have a way to ignore the missing write permission and still make changes to read-only files we own without us having to change the permission first. For example, the VI editor, a more advanced tool than Nano, allows changes to read-only files. Here, when I attempt to save the changed file using standard write command, I will get a warning too. However, this editor offers me an option to save this file despite being read-only using a modified write command by adding an exclamation mark to the standard VI editor write command. You can see that the file is now smaller as I was able to save the changes in the VI editor despite not having write permission. It is important to understand that permissions for regular files control what can be done with the file contents, not what can be done with the file itself. Many Linux users, including experienced ones, do not understand this important distinction, mistakenly believing that making a file read-only will prevent them from being overwritten or deleted. My backup file is read-only, but I can still overwrite it using copy, move, or rm commands if I use the -f force option. Here's a forced rm command example with the read-only backup file. No prompt, no warning, backup file is gone. Ultimately, it is the directory permissions where the file is listed and not the individual file permissions that control what can be done with the file itself. I will revisit this important nuance in my next lesson, where I will explain permissions for directories. Alright, let's explore how permissions set for our files affect how other users can access them. Let me use another terminal where I will log in as user Bob. Bob is a member of group Pi, which my original account Pi belongs to as well. This means that user Bob's access to files associated with Pi group is controlled by the middle 3 flags of the permission string. Right now, Bob has no access to password.list file. Any attempt to view or copy the file as user Bob will be met with a permission denied error. For example, when I use a text editor. User Pi can grant read access to the password file to Pi group, therefore allowing Bob to access that file. Now Bob can copy the file or view the file contents, although the original file is still unwritable to user Bob. Any attempts to change the file as user Bob will be met with a permission denied message. How about granting write permission to group? Well, this is a bit more complicated. Allowing open write access to your files for group, or especially others, carries considerable risk and needs to be done very carefully. It is a broad topic, and I will discuss it in a separate lesson. Let's try another user for read access. Now I am logged in as user Alice. Account Alice is not a member of group Pi, therefore Alice accesses password.list file as others. Right now, Alice cannot access the password file as others have no permissions to it. I will get a permission denied error if I try to copy it as user Alice. That will change if user Pi will set permissions, for example, allowing others to read the file. Now Alice can access the file and perform operations such as copy. User Pi can take away the access to password file for others at some point later, but Alice gets to keep the copy. That's it for the file permission basics. The next video will discuss permissions for directories. I will also introduce a numerical method for changing permissions and show you how to change the permission defaults. Thanks for watching.